Hi, everyone, and welcome to our Module 7 how-to. I'm going to jump right in here. We're looking at the first page of Module 7, where we are solving additional equations, building on what we discussed last week, and also going to look at absolute value and inequalities this week. This list of steps is not necessarily the order in which you want to do every problem. It's just kind of an outline or summary of strategies to use. For most equations, and I'll talk about the exceptions, what you would want to apply first would be the distributive property. Then combine any like terms that are on one side of the equation, then add or subtract any quantities to both sides of the equation, like we were practicing last week. And lastly, multiply or divide any numbers on both sides as your final step. And we looked at that in some problems last week. So that's just a rough breakdown of how you might want to think about approaching most problems when solving equations. Distributive first, then combine like terms if they are all on one side together, like all on the left or all on the right. And then start going through those steps that we practiced last week with adding or subtracting something on both sides, and finally multiplying or dividing something on both sides. We'll get to these other things that you see in the list, like clearing a denominator if you've got fractions involved, working with literal equations, and absolute value. I'll say more when we get to those examples. Let's just look at this first one now, where it says to solve and check the equations that you see there. So there's no parentheses throughout this equation, so we don't need to distribute anything. Then we move to, are there like terms on one side? And notice there are not, because we have one X term on each side and one number term on each side. So nothing is alike on one side of the equation to immediately combine. So then we move on to addition and subtraction of something from both sides. And you can approach this in a couple of ways. What I am going to do is focus in on the variable terms and say, I want to take this 4x away from the left-hand side and also subtract that 4x on the other side to balance my operations. I get that term out of the way on the left, so I'm only left with -7. And then I combine it with 6x on the right-hand side, 6 minus 4 for 2 on the x term, and then I bring down the number term -1. Then I need to look at my number terms, -7 on the left, -1 or -1 on the right. And remember, we want to get variable terms to be more and more by themselves as we go. And so that would mean we want to move this number term from the right-hand side. So let's add its opposite and do the same on the left to balance. That goes away on the right. So we just bring down the 2x. And then we combine on the left, -7 plus 1. That gives us -6. And so now we're finished with the addition and subtraction step. We move on to multiplication and division on either side. And so we've got a 2 times x going on right here, 2 times x. So to undo that operation and get the variable more by itself, we want to take the opposite, divide 2. So we'll divide 2 on both sides, and that leaves us with x by itself. So we're getting somewhere here. And on the left, -6 divided by 2 is -3. So there we have it, x equal -3. And if you wanted to check that, you could plug it back into the original equation. Let's just write down a quick check. 4 times -3 minus 7. That works out to -12 minus 7, or -19. And then looking at the right-hand side, 6 times -3 minus 1. 6 times -3 for -18 minus 1. And that we get -19 on that side as well. So that confirms that our answer we just got of -3 is the solution. All right, I'm going to leave that up there, but take out this checking that we did down here so we can have some room for the next example. Notice in this one that comes second, we have some parentheses involved. So we're going to use that distributive step this time around, particularly right here with the -2 next to the parentheses. So I'll write it all out, but as you get more comfortable, you can feel free to um, just write it out how you want to. We're going to take this -2 and multiply it by the first term and the second term within these parentheses. I'm going to come down here and write our first line, bringing down the 4x that's in the front. And then we've got -2 times the first term of x, and then a -2 times the second term of -4 equal 10 coming down. And there we've done our distribution. We can simplify the writing of this. -2 times x is -2x. -2 times -4 is +8. So that translates to a +8 right there. Now what? We have like terms on the left. Remember, like terms on one side of the equation is something you want to see if you have after applying any distribution. Or if there's no distribution to start with, still ask yourself, can I combine like terms on one side of the equation? And that's a yes. For this example, 4x minus 2x are both on the left. And so we take 4 minus 2 for 2 on the x, and then bring down the 8, bring down the 10 over here on the right. And now we're at the addition and subtraction step. So next up, we would want to say, okay, I have a number term on the left and the right, variable term on the left. So it would help me get my variable term more by itself by moving this number term. So I'll take -8 on both sides. That gets me to a place where I can just bring down 2x and 10 minus 8 for 2. And I just realized I wrote that 2x kind of under the 8 minus 8. You can set this up to be more intuitive for yourself if you want to kind of align your writing, say like that, and write the 2x as if it's coming down. All told, after this step, we're looking at 2x equal 2. So now we're at the multiplication and division, the last step of the process in solving the equation. And we have a 2 times the x variable. And we want to undo that by dividing 2 on both sides. So divide 2, and that gives us x by itself on the left. And 2 divided by 2 equal 1. So x equal 1 on this example. And I would encourage you to confirm for yourself when you plug in 1 back into the original equation for this example, this equation here, plug in x equal 1 and work out the left-hand side, because notice the right-hand side is already just a number, 10, and confirm that you get 10 when you substitute 1 into that left-hand side. Notice on the next example that you have 3x minus 5y equal 15, and you're asked to solve it for y. So I'm just going to take away what we had from those previous 2 examples and take you back up to our summary of different things we might see related to solving equations, and highlight the fact that we're now looking at what's known as a literal equation. When we're asked to solve for one variable and there are more than one in the equation, that's that literal equation idea. So let's take a look at this. Solving for y means we want to treat x terms as if they will go with the other stuff for number terms aside from the y. on one side by itself. The objective being get y by itself if we're solving for y. All right. So we treat this as if it's something we want to move away from the y term, 3x. How can we do that? Since it's understood positive, no negative sign in front of it, then we would say, okay, that needs to be subtracted on both sides. In order to get rid of that 3x, I'll subtract it on both sides. Now, contrary to what we're used to in combining things when we do this, now when we look at 15 and minus 3x, we have to say those are not like terms. Therefore, we will just bring them down and not try to combine them in any way. So that might feel a little bit different than usual. And then on the left-hand side, we would say that is negative 5y coming down. The 3x term has been eliminated. And we're one step away from reducing this equation down to just y by itself. We've got a negative 5 times y on the left-hand side. So we would divide negative 5 on both sides. You can just place all of those terms on the right-hand side over the negative 5. And there we have solved what we call a literal equation for y. And notice there are still variable terms on the other side of the equation, but that's okay because we don't know what the value of x is, don't have any information to plug in. So we leave it like that in the end. And then lastly, the fourth example that you see there on the screen, notice has absolute value signs around the terms on the left-hand side. And so that falls into the bucket of our summary of types of problems that we'll come across in that absolute value equations bucket. And notice it says there, when you see this, solve two separate equations, one of them set as is, and then the other set to where the number on the opposite side of the absolute value signs is negative or made opposite. So let's break that down in this example. So first, we will write two separate equations, 3x minus 2 equals 6, just like we see it there without the absolute value signs. And then second, write without the absolute value signs and the negative or opposite of the number on the right. We'll solve both of these equations separately. So here we're looking at minus 2 on the left. We need to eliminate that. Bring down a 3x equal 8. And finish this by dividing 3 on both sides for x equal 8/3 as one solution. And then we're going to get a second solution from this other setup. The steps will feel quite similar. We've got plus 2 as the first step, eliminates the 2 on the left, and then slightly different number resulting on the right here, negative 6 plus 2 for negative 4. And then divide 3 on both sides. That will get us an x term by itself on the left, and we have negative 3 over 4 on the right. So all together, our solutions are negative 4/3 and 8/3. We're going to pick up with another video on the next section, but that's a good run through of 7.1. We'll see you on the other side with 7.2.